Welcome, ladies and gentlemen, to another episode of Mr. Ballmer's YouTube videos. Today is Sunday, the 4th of October 2020. As you can see, right a 6:15 in the evening, right from Switzerland. And you can see right here something which I presented you some time ago, which is something very special because you can have access to a quantum computer. This is the D-Wave website and its website Leap, actually in, well, Leap 2. So we have some very exciting news and let me share them directly here to you. This is my dashboard, which I created some time ago, and the news is that you have now the possibility to access the Advantage quantum computer. It's now available in Leap since the 29th of September 2020 and actually available to the supported or to the countries they opened service to. I think around or from the 8th of October 2020 in every of those countries. So I have already access right here from Switzerland, and as you can see, I already used some time of it. It's the hybrid solver total, which you can see I used it for in total here. It stands 2 seconds and some milliseconds, but let's go through it. First, what is the big news about the Advantage quantum computer from D-Wave? It's that you can apply for 1 minute access to a D-Wave quantum computer. And the newest version, which I set up, is the Advantage_System 1.1. This is the newest quantum computer from D-Wave with 5,436 qubits, as you can see here, and status is online. Quantum computer status online. This is the average time it takes for average computation. This is the estimate waiting time, of course. The average time is, of course, much lower, and I expect it to be right. So, okay, what we can see here is also the temperature in millikelvin. It's quite cold. But the phenomenal thing what we have right now is they doubled the qubits, and as you can see, I have access to 5,436 qubits. This is actually the Advantage 5,436 qubit processor from D-Wave, if you want to call it that way. Okay, so I already did some tests here. Run them. It was actually quite early in the morning when I did most of those tests, because when the information came in, I just heard it and I directly went to it at that time. So as you see, available, and I got the information right very quickly, and then I got into it. So some also interesting thing is that you can set up the solver API. I will show you, well, I showed you that how to do that, but there is some user API token, some specific token which is hidden right here, because with that you can get access to the specific account, and this is my account for the moment. I have a developer plan. I got access quite a long time ago, and so therefore somehow I got access to the newest one, which doubled the qubits. And it's quite remarkable that I can already use it, and I used it. And let me give you a short update about it. What I can tell you from the update is, and let me show that to you. You see the hybrid solver total, then you see some hybrids, binary quadratic model version 2. Here you got some additional information. Then you have the hybrids underscore V1. Here 2 still available, 15 minutes. Time available here. And because they changed the access, how you can access which one, because the hybrid takes advantage of different kind of different quantum processors. It depends to which kind of problem you submit. It will take advantage to the best on its approach by using the right quantum computer for it. So in a short, you submit a problem and it's somehow determined which quantum processor fits that specific problem the best to solve it probably the fastest. Yeah, I say probably because it's a hybrid and it will choose from different ones. So we have the direct quantum processor unit. Total time of the advantage system I used is, as you can see, 14 seconds so far, which is included in the time here, which in total I have from here. So I used it for that month period of time, 24.71% already, because I run some few examples. As you can see, it goes further and further on here. Well, there was another one in July with the old one, and then I waited until the new one came. So I took some samples right here, some few ones, as you can see, right on this one, on the advanced system, which has, as I said, double the qubit. So problem submitted 21. Then the average time per problem took some milliseconds to solve in average, because I submitted quite some very tough problem. Otherwise the time to solve it would be, yeah, I would say probably much lower. But because I submitted very tough problems, it took a little bit longer time for the quantum process to solve it. So still 45 seconds left from that 1 minute, and 66 estimated 66 problems remaining, which I could submit on the advanced system. Then we have the old one, the D-Wave 2000Q _6, which they upgraded at that time to 6. And I also submitted some problems here. You can see that it took quite less time. The reason for it is because there were different problems, or I need to say that for the moment, different approaches to submit to the specific quantum processor. And this is the old one, and it got 11 problems submitted. Still I have some few estimated problems remaining, which I can, and I will show you how to just send very normal, well, what is normal, but I mean a very easy, better to say, very easy problem to the to the quantum computer. I will show you that in a minute. So to set it up, you just need to go to D-Wave Leap or D-Wave Leap 2, and then subscribe, put all the information in. You need to connect it to some other kind of service in some way that you can show that you have at the end to say actually, or not at the end, but to say that you can have such that you can have quantum processor time, which you can really submit your own quantum code, or actually even in today's time code, which then the hybrid solver will figure it out to which quantum processor it will go, and will do the calculation and give you the result back, hopefully giving you the result back, right? So you have minimum 1 month free access to a real quantum computer, or to a, let me put the real back for a moment because it's in hybrid, to a quantum processor from D-Wave, okay? Because there are a lot of companies out there. IBM is one, and there are others too. Microsoft has one, but they have also services they set up to access for the public, for businesses. And yeah, as you can see, I have set up this the right way. It takes some knowledge to set it up, but let me give you an example how to submit a problem. So this is the CMD. It's called, you go in, you go to search and put in CMD, executed with administrator rights. As you can see here, it's in German written, but this is with administrator rights, and I set it to well, this is the Ocean toolkit, which I set it in a specific state. Let me say it that way, okay? Let me say it that way, in a specific state for protection. Okay, so that's why it is in brackets before the actual file path. Okay, so I set that up already, and let's do some stuff here for a moment. Okay, let's extend that a little bit further down. Let's go to the quantum, to the advanced one first. So okay, here we go. Let's put that a little bit further down, and let me show you how I do that. Okay, let's put in there. This is like a folder you have. Well, you need the Python program installed. There are other things in it. So let's ask which Python version it is. So you can see the Python version is 3.8.6, and I think this is the newest one. Otherwise we can also ping it and upgrade it. But let's go to the D-Wave and look for what it offers to me. This is the D-Wave quantum company, and I access it, and D-Wave Cloud Client Interaction Configuration Tool. So I'm accessing the D-Wave system right now. And this is real, huh? Just in a normal way, without actually using the Python program to execute, or the IDE workspace, which you also can go to and access the quantum computer. I can show you before I go here. Oh, let's show it. Let me show that. Okay, I already showed the version. Then what else I can do? I can ping it. Ping the QPU, quantum processing unit, by submitting a single qubit problem. Okay, D-Wave ping. Let's see. it uses the solver, the newest one, boom, and here we got it. Okay, so from here I put the information in. Where was it? Here, D-Wave ping, and it used the endpoints, which is actually here. It used this one, the solver API endpoint, to access the D-Wave system, and then it uses the solver, which is the quantum processing unit advantage underscore system 1.1 online advantage system. So it uses the quantum processing unit, and that's the newest one, and that is what you can see, using solver advantage underscore system 1.1. I had to set it up before in the configuration. I set it up to my account specifically, and that is what it's using. And I will show you when I update here that you can see I submit another instance to the quantum processing unit, to the newest one. So then you can see additional information, submit problem ID. It will appear then here, right here. Then wall clock time, solver definition, fetch time, problem submit and results fetch, total time, and so on and so on, quantum processing unit time, get the annular time per round, 20, and so on, as you can see. Additional information, I do not explain this one here because it's going a little bit more into detail. Here you can see how long it takes for the quantum processing unit to actually solve it, or get me an answer back, if you want to call it this way. And I'm back here. So let's update this for a second, and boom, here we go. And the new problem is updated, or actually here, as you can see. So let's see if that's the one. And here it is, right here. Sunday, October 4th, 2020 p.m. This is I think the universal time, but it's completed, as you can see. So that's what I just did. Simple thing. So let's see. D-Wave. So then I show you the solvers, get solver detail. This is the solver. I want to get a little bit more detail about the advantage system 1.1 quantum processing unit. Quantum processing unit advantage underscore system 1.1. Okay, so D-Wave solvers, and the result is coming, and that's the answer. That's what I sent to the D-Wave system. The solver is advantage underscore system 1.1, and all the parameters here, another offset for each working qubit. So you see different information about the processor. This is the lower noise. The lower noise is false because this is the lower noise, the old one here. This is the new one, this one here. So running active qubits 5436, as you can see the name. I said again, the name is advantage underscore system 1.1. Then we have the number active of qubits 5436. Online, it's true, so it's online. That's why I got the result back. And the quantum processing unit is true because it's a quantum processor. And the software is, yeah, I do not go into this because I'm just using the CMD which everybody has on Windows. When you use Windows, you have CMD and you can access it. I suggest with the administrator rights. So, and let's see what else we have. So yeah, what we can do is submit a sample. We can submit a sample. And we can go into this. Oh yeah. Here we go. We got some additional information by putting in -- help. After we said dwave space sample space -- help. Submit using formulated problem and return samples. And so let's go for the random problem. Submit the valid random problem using all qubits. So I'm using all the 5,436 qubits to solve the random problem. And this is just like that. Oh, let's see. D-wave sample -r. Here we go. And come on. Boom, here we go. That's a very simple one, as you can see. That's what we got. Yep, that's what we got here. We got a problem. We submitted the problem, a random problem, and result. Sample qubits using qubit couplings, biases couplings. Number of samples 1, samples the occurrence 1, energy used DAC, and that is the result of it. But let's go for a more detailed. Let's go for a more detailed one here. Not of that, I could run. Let's make another one here before I go to show you that one. D-wave, then we have sample, then we go to the random problem and how many times we want to use that. We go with the number of read samples. Let's put that into just, for example, 10 and 10. Okay, this doesn't make really sense. And see, I used a little bit more here. It doesn't make really sense, 10 or more than 1, I guess, for the moment. The variables, let's put the variables that you can see what it's really doing. Let's go to 100 for a second. And then we go to the variables also. So this is going to D-Wave, using the D-Wave quantum computer, advanced quantum processor, then using a sample, the random problem, using the random the number reads of integers by 100 times or 100, and showed the verbose increase output verbosity. And let's extend that a little bit here so you can see what's going on. Okay, have a look. Enter. Go. Let's see what it's doing. See? And here we go. Go again. Boom. Finish. And let's scroll up a little bit. It's just random numbers here. But as you can see, 0, 1, 1, 1, minus 1, whatever, right at the moment. So it's using it. So I cannot go further up, but you saw different numbers up there. And let's update it. So you can see I used a little bit more here. Let's go to the advanced. I used also a little bit. Now we have 24 problems submitted, and we submitted the normal one here. This was the random problem, and this was the one with 10 times integer count. So that is how you submit some, what is not really a problem actually, but it's just to show you that it works. Because let's go to resources. Then we have interactive demos. Let's run a demo, okay? So here we have a demo, factoring by running a multiplication circuit in reverse. I'm not going through it, I'm just continue. Then we choose the highest number because it should calculate 49 possibilities. Select the number to factor on the quantum computer. Of course, I do not want to use smaller ones and use the highest one. It can calculate. I want that it will be solved in an instant. Okay, let's go further. Explanations are here. You can see factorization of 49 divides 9. What will be the result? How trial division works to find integer factors. So calculating 49 divides factorization divides 7 is 7 because 7 times 7 is 49. 2 times 7 divides and result, divides and result. So you can see more information here about the bits, the factorization. You can get more information here. How classical computers factor. How classical computers factor. So let's go and see how a quantum computer circuit is doing this. Here we go. You got the point? Okay. Multiplication using a Boolean logic circuit. Okay, that's a Boolean circuit. Let's see, not a quantum, it's a Boolean circuit. 3-bit multiplication, 3-bit multiplication circuit to find the product of two factors, because these two factors make multiplied by itself 49. Okay, more information are here if you like. Then go forward. Then multiplication as a constraint satisfaction problem. 3-bit multiplication circuit again, and we go we go further. Classical computers using an AND gate, and the quantum computer using qubit and couplers to find the solution. More information are here. Programming the quantum computer. So an AND gate, and it uses more combinations here, if you want to call it that way. So let's see. Creating the mapping. 3-bit multiplication circuit transformation. From the circuits, normal computer, transformation, to the qubit circuits, let's go a step back for a moment, to the qubit couplers, to the qubit couplers. So okay, from the classical computer circuits, transformation to the quantum computer couplers, or the qubit, and this is how a quantum computer will solve it. And that's the, well, probably, if you want to call it topological map, or the map, there's the couplers. That's how a quantum computer is solving it. The combinations of combinations, and more information, excuse me, more information are here to be written, or that you can read it there. So we go forward running it on our quantum computer. So let's run it and go. And that was solved in 0.029 seconds. Of 75 samples, unique solution is 1. The solution of the factorization of the number factorization, or the factorization of the number 49, is 7 and 7 in reverse. 7 times 7 is 49. 7 times 7 is 49. Good. More information can be read here. So because solutions are probabilistic, we typically ask for multiple samples whenever we run a problem. Many samples can be returned without significantly affecting the overall runtime. Why? Because a quantum computer can process not only, let's say what a processor can do. It can use 1 and 0 at the same time. A classical computer only uses 1 or 0. It cannot use 1 and 0 at the same time. But a quantum computer can use 1 and 0 at the same time. And that makes it extremely powerful. So it can be 1 and at the same time 0 by it can be 0 and 1 at the same time. And that in combination. So you just factored a number by solving a constraint satisfaction problem on the D-Wave quantum computer. Yeah, we solved it, and I have another one more. I will show you that. So let's continue here. Recap, more information here. This is a quantum processor. It's usually in like a special refrigerator or cryo, I don't know, in a special cooled, very, very cool environment at the moment. Hopefully we will have quantum computers that you can put on your desk or, you know, in your home. Someday you will. We will see. At the moment it uses it needs a very special environment, a very cool environment, as you could see with the millikelvin. So we finished that. We can go to further on information, but let's go back to Leap and to my dashboard, and you can see I used a little bit more of my quantum computer access time for this month or for 1 month, and the problem which we just did is this one completed. Check, check, check. And let's go to another one. Let's go to another one. Interactive demos on our sources. So we run this one. Network analysis using optimization, and let's go into it. Here we go, more information here by clicking that one, that one, searching the optimization problem, searching. This is an optimization problem to optimize which one is the best. Next, an example social network from Romeo and Juliet. Romeo and Juliet. Here we go, to all related to others. Show, here we go, tuck, 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 tuck. We find optimal solutions. Excuse me. So an example social network from Romeo and Juliet. This is just an example. Here we go to the next one. Introducing imbalance. So there's a line between them, how we bring them together. Lord Capulet. So let's see. Romeo, Lord Capulet. It seems to be the Juliet is the one who is wanted here, right? So let's continue here. Programming the quantum computer. More information here. It takes some calculation here. Let's go forward. Then real world samples. My gosh, what kind of thing is this, huh? To find it. So try it on a DWF quantum computer. View a Syrian. So let's run it. Runtime is 0.023 seconds. Of samples, 50 samples. Unix solutions 4. We got 4 solutions. So we run another problem. Let's look at this one. This one is the CPU. Still running, and takes some time. Well, the quantum processor already finished it in 0.97 milliseconds. Seconds. It is 497 milliseconds. Okay, so while a classical computer for this particular problem would still run, and which is probably quite a fast one, maybe. Yeah. But this is just to show the performance, what can be achieved. Just an example, okay? It's much faster in the future. So more information you can. For more information, go here. Then we go forward. We have other things. It can be applied for medicine, for communication, directions, directing, and so on. It can be used for radio towers and so on. This is further examples in optimization. Okay. Then we have it done, and we go back. We go back and let's update it. We used it a little bit more, and we have another problem submitted right here. Is it? Let's see. Did we? Did we? Yeah, we did. So, okay, this is just a short example. Let's get to the bottom of it. Here we go. And let's ping it again for a second. Just for a moment that we see it's still working, and here we got the results. And it's another problem submitted. Let's not put that one again. So see, we got it here. Problem is submitted. So it's working. It's working. And I could show you even much more. But that is it for the moment, because here you can get access to more information, to more samples. We can run it like this. But for the moment it's okay, because you can try that by yourself. Then you go into the D-Wave system, where you can code it, where you can submit your code, your quantum code, your what you like to submit as a programmer, or if you have knowledge about programming, and then get direct access to a D-Wave quantum computer. So this is just an update for the advanced quantum computer, which is available. And yeah, I mean, you need to read some few things to understand what I mean, but you will get access to a quantum computer from D-Wave, at least 1 minute for free every month, if you do it right, like I did. And yeah, that's for the moment. I updated you with some news. get involved into it. This is your time to go into the quantum field by using quantum processors, even for free. And this is a very, very, very exciting time, because quantum processors, quantum computing, the new era, we are in the quantum age, and artificial intelligence will be extreme. So this is your time. Get involved, do what you can. If you're a programmer, if you have programming skills, get into it and do something great that humanity can benefit from it. Thank you very much for your time. Thank you very much for listening. And if you like, you can press the button to subscribe to my videos for more to come. You can like my videos, this one for example, if you like, and of course you can share it to your friends and people you know. It would be greatly appreciated. Thank you very much, and as always, thank you very much, and peace in.